is Joel, and in this video we will kickstart some cool stuff with multicast. Right, multicast is a very bit of an underrated protocol, I would say, probably because you it's not very widely covered in any of your certifications. At the same time, you don't see a lot of applications in your day-to-day life as well, right? But it's a very interesting protocol, and you find a lot of applications in SDA and SD-WAN and all of that, right? So it's very important to have your fundamentals right with multicast. And recently I was troubleshooting a network and I was not able to or I was mainly stuck for a couple of days, and that's where I kind of went back to my basics and I kind of recapped whatever I knew in multicast. So I thought I'll make a quick series of videos, especially for people who are probably like preparing for their exams or maybe for interviews. It would probably be helpful, right? I'll be mainly following this particular Cisco Press book. It's a very nice book written by, I think, Bo Williamson, Developing IP Multicast Networks. I had read this quite some time back, and so I had to recap, but then this is a very good book when you're starting out with multicast. It's probably not very there are a bunch of things which are probably not covered here because it's a very old book, right? Probably in the 2000s. But then I would really recommend you to start with this and probably move to other books, because it gives you a very good understanding about multicast. All right, so let's get started without wasting any time. All right, so the format of the series is going to be very similar to how I've done my previous series. There'll be a bit of theory, probably a few videos probably is going to be only theory, and then there are going to be labs, right? We are going to obviously use EVNG to simulate some labs and do some packet captures and understand how the multicast traffic is controlled and how the data flows and all of that. Cool. All right, so to start with the first part of the discussion, let's go back one step, right? Instead of starting from traffic, instead of starting from multicast, let's say you want to start from traffic. What kinds of traffic do we have as of today? You have your unicast, you have your multicast, and you have your broadcast, right? Now, if I want to quickly give you an example, say we have a your video server, right? There's a video server and which is streaming probably at a rate of let's say 6 Mbps, right? And you have the rest of the infrastructure, right? So this is your server, but then you have a switch here, probably there is a router, right? And then probably you have the internet, and there's one more router here, and probably you have a switch, and you have your hosts which are connected here, right? There are people sitting here and watching your movies, right? Probably we can also add over here as well. Let's say 2 more hosts over here too, right? So we have 4 hosts, right? 1, 2, 3, and 4, and we have 6 Mbps of stream over here. Now, when you're talking about unicast, right? When you're talking about unicast, if all the 4 guys, right? If all the 4 users wanna watch this particular stream, right? The video, probably a movie or whatever, right? So this guy will have to stream into 4, right? Because it's going to be unicast, so he has to send the packet from the video server to this guy, and then this guy, 3 and 4, right? So it's going to be 4 streams, 4 individual streams. So this is probably going to consume 24 Mbps, right? So the video server which you see over here will have to send data at a rate of 24 Mbps, right? So don't you think that's not really scalable, right? Imagine you have hundreds of users, right? You'll obviously reach a limit where you will not be able to stream beyond certain point, because obviously you are limited by layer 1, right? You can't stream some certain point. Probably you can do Mbps and gigabit as well, but after that you have a limitation, so you can't really use this. Now that being said, okay, so unicast is out of is off the table. So let's think, can we solve this problem using broadcast, right? Now with broadcast, let me use probably a different color. With broadcast, what happens is that you have just let me use a different maybe this is better. All right, so with broadcast you have just one single stream, right? The the load of the video server is lifted or removed, right? So it's going to be just one single stream, that is 6 Mbps, and then the switches which you see here is going to broadcast right over here in this direction. So the switch is going to take the packet and send it to all, or flood it on all the ports, right, because it's a broadcast packet. Now, couple of limitations here as well. You see here, once it reaches the router, it is not going to proceed, right? The router is going to say, no, I can't send a broadcast stream anywhere, because broadcast is just limited to the L2 domain, right? So as a result, you probably are losing out on stream. The rest of the two folks can't even stream, right? And here as well, what happens is, user number 1 and user number 2, right? Let's say user number 2 doesn't want to watch the stream, but he still has to, or will be getting the packets, right? Because it's a broadcast, right? The broadcast packets are, gonna be sent, because it's a broadcast, right? The switch is going to flood it on all the ports. So the user number 1 and user number 2 are forced to get the stream, right? Which is again not ideal, right? If I really don't want that data, what do I do with it? So that's basically trouble. So broadcast also doesn't solve our problem. Now that's where our multicast comes into play, right? So the multicast, what it does is that you have, or using multicast, what you can do is, it's going to be still a single stream, right? So probably let me use a different color. I think I'm running out of colors. Let me just, okay, probably yellow would be better, or maybe blue. All right. So in multicast, you still have one single stream, just like your broadcast, but now what you can do is that you can send it across, right? Not just the router, because it's not a broadcast, right? It's a layer 3, so you can send it across, I don't know, maybe your internet or across the network, right? It can cross the boundary. It can be routed, right? It can be routed, so it can cross the boundary, and along with that, you can also decide who wants to watch this. So let's say the user 1 wants to watch the movie, right? He can subscribe to that multicast stream, and if this guy doesn't want it, he can he doesn't have to. So that way the switch will not send the packet in this direction. So you have control here. So now I think you understand mainly the difference between all the three, right? Unicast was from one source to one destination. As a result, it strains or puts a lot of strain on your network, because you'll be broadcasting, or you'll be sending data at 24 megabits per second. But in broadcast and multicast, you send single stream of data. But multicast really wins in this particular case, because one thing is it can be routed. Second thing is you have control on who would want to subscribe to it and who would want to watch, right? So that's basically the reason. That's one of the main use case of multicast, right? Now this is a very interesting question. I remember someone asked me in an interview and stuff, right? This might sound very tricky. It's actually pretty simple, but I personally ask this question sometimes in interviews as well, and I get interesting answers. Netflix and YouTube, or any other video streaming services, right? Amazon Prime or whatever it is, right? So your video streaming services, do you think they use multicast, right? That's a very, so the first sight of it, or when you look at it, or when you hear the question the first time, you probably jump and you say yes, right? But then, because it appears to be, because you have a video server, think of Netflix as a video server, and then you have millions of us sitting and watching, so you might think yes, it is multicast, but no, that's not, right? So any of these streaming services are not multicast services. Reason being, take something as simple, right? I'm watching a video of, I don't know, a cute dog on my laptop, right? And YouTube or whatever the server is over here, right? It's all unicast, because when I'm watching the video, right, I'm the only one who is watching it, right? Maybe yes, there might be few other folks, but they would have probably started watching before me or after me. It's very rare that two different users at two different locations started watching the video at the same time, right? So all of us, whenever we use the streaming services, we are kind of like, we are doing it on demand, right? They are video on demand services. This means that they implicitly require your unicast functionality, right? So that's something which I wanted to clear, right? Because when people say, give an example for multicast, and if you jump on and if you say Netflix and YouTube, that's not going to work, right? Now the follow-up question to that be why? Why are why don't why is multicast not used, right? So one of the example for multicast I would say is your live streams, right? Your live stream. So live stream is an example. Like, I mean, I know that you have live stream on YouTube as well, right? So that would kind of qualify as multicast, because when the stream is starting, right, all the clients, right, in the world, right, are basically whoever is watching, right, they are basically watching the same stream or the same video, right, at the same time. So that would kind of qualify as your multicast, but it's not really implemented that way. The reason is, I would say, things on the top of my mind is your ISPs, right, service providers. They generally filter out your PIM and IGMP messages, which are really needed for your multicast, right? PIM is basically your multicast routing protocol, right? And these guys, the ISPs, basically filter them out. And second thing is, keep in mind, multicast implicitly requires that end user device, kind of like end user device actions impact the forwarding state of your multicast router, right? So this means that any multicast event, for any multicast event, all the end users must have some way to kind of inform the multicast routers on the internet on how the multicast routing should take place, right? Which is really not scalable, right? Imagine millions, having millions of users, right? Sometimes whenever you have a live stream from some of these YouTube, I don't know, celebrities, right? You have millions of people sitting and watching, right? Or probably it's someone is streaming, say, a tennis match or or F1 race, right? You have millions of people sitting and watching. When I say millions, it means that you have millions of clients, right? So in multicast, you have the concept of joining a multicast group, right? So all these clients will have to join the multicast group, and there is certain amount of signaling involved, right? Certain amount of messages which has to be exchanged with your multicast routers and switches to make multicast work. Now, yes, in one front you are getting some advantages of multicast, the ones which I showed earlier, but then you are kind of nullifying that with all the overhead, right, because of all these control messages, right? So when you look at the benefits, right, they kind of or let's say the overhead which you see here kind of outweighs the benefits, and as a result it's not very optimal to use multicast in this regard, right? So that's the current situation when you talk about multicast and why it is not being where it is implemented, where it is not implemented, and so on. All right, so now let's move on. Let me just get rid of this again. All right, maybe this one as well. All right, so the next part we are going to discuss is, let's say, the components, right? The components of your multicast, right? What are the things which you would need to kind of make multicast work, right? Pretty simple question. Now, things at the top of my mind is your first one, I would say, is your class D address, class D range, right? You guys know what is class D range? I think I have a page open for that. Do I? Probably, yeah, over here, or maybe not. Let me just Google that, right? Just to recap, what is your class A, B, and C? You probably have it on Wikipedia either, right? So this is your classful addressing, right? We probably have read this, or we have probably used this in our day-to-day networks. So you can see this is class A, right? This is the start address and this is the end address, basically starting from 0 to 127. Then 128 to 191 is your class B. Then you have your class C. See here, this is the class D address, right? Starting from 224 going up till 239, 255, 255, and 250. So this is your class D address. So these addresses are only used as destination addresses, not as source addresses. Just remember that in multicast these addresses are used, but these are used as just your destination addresses. So that's one of the requirement, I would say, having your class D range. Second is What else? You would also need some applications, right? Something as similar as your VLC player. I think most of us know about VLC, right? Most of us watch our movies on VLC, right? One of the most open source of consumed players. So you need to have such kind of a multicast application which can understand multicast, which can stream multicast, receive multicast, right? So that's one of the requirement. Then very interesting. The next component is very interesting. So you have your, going back to the same example, you have your video server, you have your router, and say you have your clients here, right? The various clients, right? You have your various client number 1, 2, 3, 4, and so on, right? Now when a particular client wants to receive multicast stream, right? Say R1 wants to receive the multicast stream, there needs to be a way to kind of tell the upstream router that it needs the multicast stream, right? There should be a way to communicate that. So that's where the third component comes into play. That's your IGMP protocol. Right? Your IGMP protocol, Internet Group Management Protocol, right? So that is a protocol which is used to tell the router, right, when they want to receive the multicast traffic. Now this brings in another interesting problem, right? Let me just change this topology a little bit. Let me draw it again. Right, let's change the topology a bit, wherein I have the video, I have the router, I'll have a switch this time, because obviously you don't have your clients connected to your router, right? In any of your enterprise networks, you're probably going to have your clients connected over here, right, to a switch. Now we talked about IGMP protocol, where the clients are telling the router that it wants to receive this guy is telling the router that it wants to receive the multicast packet, which is good. But now imagine the multicast packet is coming down like this, right, from the video server. From that it comes to the switch. Now the switch has to decide, right, or the switch has to figure out where to forward the multicast packet. If you go back to your switching basics, right, how does switch forward packet? Based on MAC addresses, right? Now with multicast, right, you use what we call as the multicast MAC addresses, right? You don't use your traditional MAC addresses. You use your multicast IP, right? Basically your class D range, that's a multicast IP, and you use your multicast MAC addresses, right? But I also told you that this multicast addresses, whatever you use, either IP or even the MAC, right, we don't use it in the source. We always use it in the destination. Keep that in mind. We always use them in the destination. So when a multicast packet is formed, the multicast IP and the multicast MAC is always used in the destination and never in the source. Doesn't that kind of break the working of your switch? Because for switch to work properly, one of the if you look at the workflow of a switch, how the switch works, right, it just does it based on two things. One thing is it does source learning, right? So whenever there is a packet coming in from any of the client, it tries to learn the source MAC address, and in future whenever there is a packet destined to this client, it will look at the MAC table and try to forward the packet to that guy. But now, because in multicast domain we don't really have source address, I mean we have source address, but we don't use any of these MAC addresses or multicast addresses in the source address field. As a result, the switch will never be able to learn the multicast MAC addresses. Now to kind of fix this problem, that's where you go to the fourth component, which is your IGMP snooping, right? Hope I was clear with that. Now with IGMP snooping, what it does is, right, the switch will listen to some of your IGMP messages, right? IGMP is a protocol which I will talk in detail later, right? But the switch will basically listen to some of the IGMP messages between the host and the router to figure out where it should kind of forward the multicast traffic to, right? So using those IGMP messages, right, IGMP messages will basically carry some information, right? Basically your multicast MAC addresses, obviously. So it will kind of that protocol is used by the switch to figure out which clients are kind of listening to a particular multicast group so that it can send, right? Otherwise, if it's flooding, it was not efficient, right? If I basically send a multicast packet to every single of the host here, it's not going to be a optimal approach, right? You're basically going to lose a lot of bandwidth. So that is the reason you want what we call as IGMP snooping. And finally, what is the final component? I would say is your multicast routing protocol, right? Your multicast routing protocol is also equally important, because like I was showing in one of the previous example, you should be able to, probably in this example itself, if I have a router here, you should be able to send it, right, or route it, right? You should be able to route packets, otherwise it basically falls back to being a broadcast, right? I should have a mechanism to send the multicast data and route it to a particular domain and to a different subnet and so on. So that is where your multicast routing protocol comes into play, right? With unicast routing, each router kind of advertises its directly connected interfaces in a routing protocol. Then you have your routers who receive the unicast packets only care about the destination address, right? So they when in a unicast, that's how it works. They check their routing table, find the outgoing interface and forward the packets towards the destination. But with multicast routing, things, it's not that simple. The destination is a multicast group address, right? And the multicast packets have to be forwarded to multiple receivers throughout the network. So you want a protocol here to figure out where you want to send, right? In which direction you want to send, on which interfaces you want to send, right? All of that is decided by your multicast routing protocol, and you probably know of very famous protocol, which is your PIM protocol. All right. All right, so we'll jump on to the last topic in this video, which is going to be very interesting. Last part, just get rid of this again. All right, so the addresses, right? When we talk about addresses, let's be clear about two things. Let's talk about Mac. In your Mac, you have 48 bits. So you're gonna have 1, 2, 3, 4, 5, and 6. You're gonna have your 6, octets, right? 6 octets. And with your IP, you're gonna have 1, 2, 3, and 4 octets, right? I think we are very good with this. This is 32-bit, that is 48-bit. Now, one interesting trick to figure out if it's a multicast MAC address is using the least significant bit here. If this least significant bit is, say 0, then it's a unicast, right? And if that guy turns out to be 1, then it can be either a broadcast or multicast, right? So that's a interesting or easier way to figure out. That being said, let me just get rid of that. All right. So that being said, what they have done is with your layer 2 MAC address, a layer 2 multicast MAC address, right? You have reserved, the first 3 octets are like fixed, right? You can't change it, which means the first octet is going to be 0, 1, this is 0, 0, and this is 5E, right? So this is reserved, these 3 octets, right? They are like literally reserved over there, and you can't change anything over there, right? So that could be another way to figure out. So just looking at this, if you find 0, 1, 0, 0, 5E, it clearly means that it's a multicast MAC address, right? It's not unicast, not broadcast, it is multicast MAC address. Which means if I have these 3 guys reserved, what do I have left? I have 24-bit left, right? Because the total is 48 bits, so you just have 8 here, 8 here, 8 here remaining. So it's basically you have 24 bits. But here it gets interesting. Out of these 24 bits, one of the bit is again reserved, or let's say unusable, right? Or you basically have just half of it, right? So you don't have this, you don't have access to this guy. So if I remove this bit for a minute, if I remove this out of my 24, you just have 23 bits, right? So 23 bits, so 7, 8 and 8. So you just have these 23 bits which you can play around for different multicast MAC addresses, right? This one, the first 3 octets, they're basically called what you call as OU high. I think it's called Organization Unit Identifier or something like that, right? So the OUI is fixed. Now just to also kind of recap on your IP side of it, right? We talked about that the IP subnet is class D, and the class D means that you have something fixed here as well, which is 1110, right? The first 4 bits are fixed, right? That's why I said /4, right? 224. So this is literally that, and you have the rest of the guys for your disposal, right? The rest of these bits are for your disposal. So now if you see this, here it gets interesting. You have 8 here, you have 8 here, 8 here and 4 here. How much is that? That is your, 28. Just get rid of that. 28 bits. So in IP, right, multicast IP, you have 28 bits. But in your multicast MAC, you have 23 bits. You have a problem here, right? Because it would have been very, very simple if I had 28 in both the places, so that I could have had like one-to-one mapping, right? But no, here, the MAC addresses are less, whereas your IP addresses are more, right? Now there's a very interesting story here, how this ended up like this, right? Anyway, we are doing the introduction, so I could probably tell you that. So the inventor of multicast, right? I don't remember his name, right? The inventor of multicast, he was designing this addressing scheme, and he came up with a design which basically was having kind of like 16 OUIs, right? So right now I told you we just have one OUI, right? But imagine if you had 16 OUIs, right? 16 of this, and obviously the rest 3 octets are would consume or would give you 24 bits, right? So it would basically be 16 into 2 power 24, right? 16 OUIs, right? And every OUI is going to have 24 bits here. So it would have been, how many combinations or how many MAC addresses you could have is this one, 16 into 2 power 24. I think I just have the number recorded here. It's going to be something like 2, 6, 8, 4, 3, 5 and 4, 5, 6, right? So many number of multicast MAC addresses. Now this is also equal to 2 power 28, isn't it? Because what is this? This is 2 power 24 and this is nothing but 2 power 4. So it's nothing but 2 power 28, right? Which is nothing but your MAC address. So the guy who invented this, who invented multicast, he had designed it properly, right? He had designed it as a one-to-one mapping, right? Every multicast IP was supposed to have multicast MAC. But when he went with this proposal to his manager was, let's say, a bit stingy. So the manager, what he said was, we obviously can't, because I think it was costly to get OUIs, right? So go and register your OUIs. It was pretty costly. I think it was like, I don't know, $1,000 back in the day. So the manager was a bit stingy. So he went and got one OUI. Instead of 16, he just went and got only one OUI, which is 01005E, right? And then even in that OUI, he just provided the engineer with only half the address space, which means he reserved one bit for himself for doing probably some other kind of, or probably gave it to some other department. And at the end of the day, so he gave just 23 bits over here to the multicast engineer, right? So as a result, this is where it ended up being, right? So we have, as a result, because of that, we have this issue, right? And that is why we have 28 bits in your multicast IP, whereas your multicast MAC, right, you just have your 23 bits with your OUI being fixed, right? So that being said, now we could probably give it a minute. Alright, so to finally wrap this up, I think I have a slide here on how to convert your multicast MAC address to your multicast IP address, because this is very important, right? Because to understand the scenario, right? Because in your multicast domain, everything routing is basically on your multicast IP group address, and your switching is basically based on multicast MAC address. So you really need to know the mapping here. Now to understand the mapping, you look here, I just have an example, right, of basically a MAC address, right, a multicast MAC address which I have picked, 01, 005E, 0B, 01 and 02. Look at the first OUI, it kind of matches to what I was explaining earlier. So this is your multicast MAC address. Now I have kind of like kind of broken down the hex value of that, right, 01, 005E, right, basically this is a hex, and like kind of broken down the hex value. So this is the hex field, right, every single let's say every single digit which is mentioned here, I've kind of broken the hex field over here. Awesome. Now next, what do we do next is, now to convert this multicast MAC to multicast IP, we take the least significant 23 bits. You know why it is 23 bits, I explained already in the previous section. So we take this 23 bits and this is your IP, right, and in the IP I've already told you that the first 4 bits are fixed because it is 224, right, so this 4 bits are fixed. You have the rest of them at your disposal, which is 28 bits, but I can't copy all the 28 bits from my Mac because I really don't have them. So that's why what I do here is I just take the least significant 23 bits, right, and I kind of command place it here, or replace the or put it as the least significant bits down at my IP address, right. So this is done, and these are the 5 bits, right, which you're kind of losing on, right, because they really don't have any mapping in your Mac, right. These are the 5 bits. Now 5 bits constitute to how many addresses? 2 power 5, which is 2 power 5 is 32 addresses, 32, right. That is why you have 32 IP addresses or 32 MAC IP addresses for one single Mac multicast MAC address, right. So how do you get those 32 addresses? You just take this green zeros, whatever you have, and you toggle them, right, get all your permutation combinations for these 5 bits, and that's what I have displayed here, right, in this table. You can see here, I have listed down all the 32 IP addresses here, right, for this particular MAC address, right. You can see I have basically ended up toggling all this the green fields over here, right. Pretty simple, right. I mean, if you get a hang of it, no one is going to ask you to do this because your router and switches are going to do this for you, right, when it comes to multicast functioning. But I just wanted to tell you how the mapping is done, right. So we have, always remember, one multicast MAC address is mapped to 32 multicast IP addresses, right. Now this brings another interesting problem to the table. If I have a multiple, if I have something like this, right, we go back here. So if I have, say, a router and maybe I have clients, right, connected here, right. So I've been telling that in multicast, every single client, they will be subscribing to a group, right. So let's say 239.1.1.1. so this is a multicast group. So this multicast group will have one specific multicast MAC address, but the problem is this multicast MAC address is also going to have 31 other IP addresses as well, right, not just 239.1.1. there will be 31 other IP addresses which are going to have the same MAC, right. So as a result, the clients will basically be getting to make matters work. Let's assume that we have the video servers here, right, or multicast streams, right, coming from all the 32 sources, 32 various multicast IP addresses, right, from all the 32 IP addresses. So the clients here will be basically getting data from all the various sources because all of the 32 guys are going to have the same MAC address, right. So that creates a problem. So that's why there's no other way around it. They are going to get data for all of them because L2 domain or on the clients, it's all based on your multicast MAC addresses, right. Right. So basically they are all gonna get the stream from all the 32 sources, So then they'll have to take the stream and send it up to their L3 and then kind of filter out, right? If they're interested only in 239.1.1, they'll have to probably drop the other traffic, right, from the other 31 sources, right? To give a more better example, I think I have a screen here, probably, yeah. So I have plugged in a MAC address over here, and if I hit the, this is just an online tool for converting your MAC to your addresses, right? So this particular MAC address has, you can see, 32 IP addresses, right? So you can see all the various IP addresses. So even if so if I have my client which is listening on this MAC address, it will basically be getting the multicast streams from all these various sources, right? So there's no other way around it. The client will have to get the stream, will have to accept it, but then it will have to send that stream up to probably a layer 3, or maybe at the application layer it will have to filter out, right? If the application is configured to listen to, say, only one of these addresses, say 224.11.1.2, then it will have to drop the multicast streams from the other IP addresses. So that's the only other way to go about it, right? Cool. So I think that was mainly everything which I wanted to cover here. Just to recap, what did we do? Let's just quickly recap. Right. To recap, we kind of talked about the various types of traffic. Right. We talked about the unicast, multicast, and broadcast. Right. We talked about some of the very interesting problems or very interesting questions which you might get in a day-to-day, where people are going to say, is Netflix or YouTube, multicast? We answered those questions. Right. We talked about the components. Right. We talked about the components needed to set up your multicast infrastructure, right? Your class D address, you want your multicast applications like your VLC player, you want your IGMP, you want your IGMP snooping, and you want your PIM routing protocol. And then finally we concluded with the final part of the discussion, which was your addresses. Basically, we talked about your multicast MAC address, we talked about your multicast IP address, we also talked about the mapping between both, right? And that's basically what I wanted to cover here. Like I said, go back if you want more clarity on any of these topics, like a deep dive. I would really recommend reading this particular book, Developing IP Multicast, Bo Williamson, and do come back for more videos where I'll be doing packet captures and configuring some of these protocols. Thanks a lot for watching, guys. Bye.